My name is Drew Johnston. I'm the president of Energy Thought Summit. I'm very delighted to have with me two thought leaders in transportation that cover different sectors in this world, but we're going to hear both of their perspectives on transportation, what smart means to transportation, and also where's that inflection with energy, and where do we go next from here. And so today, first, I want to introduce you to Christian. Christian is the CEO of KLD. He is, first off, the KLD Energy Technology is named after his oldest sons, and they develop products that help improve the quality of life for future generations through transportation. He's a prolific inventor, technological innovator. He currently holds over 24 U.S. and foreign patents, and prior to launching KLD Energy Technologies, Okonsky worked on everything from the Dell first notebook computer to developing stealth technology for the F-22 launcher for years. He's managed numerous design ventures based in the Central Texas region. One of our friends of the show in this region as far as innovative leaders in this space. And yeah, so please introduce Christian. And our other speaker is Ian Wright. Ian comes from years of executive leadership across a number of fields. You may know most famously as one of the inventors of the fastest ever road street legal electric vehicle, the X1, but also the founder, one of the co-founders of Tesla. He is also, his senior experience has also brought him to Altamar Networks, Cisco, Net, and beyond everything else, he is now at Wrightspeed, and he's leading new initiatives in a number of sectors, but more than anything, we are excited to hear Ian's thoughts on not only where you've brought the industry, but where you see it going now that it stands on the shoulders of giants, and now we get to see what happens next. So everyone, I'd like to introduce our great, wonderful speakers. Thank you all for coming to our panel. This is the Smart Transportation Panel. I am Andrew Johnston. And I'd rather than just go into anything canned, I'd like for both of you to take a moment to describe your own companies in your own words, give our audience a sense of what problem are you solving with your current initiatives. Ian, would you mind to start?
Okay, well, let me back up a little bit and just say that when we started Tesla Motors back in 2003, in a little two-room rented office in Menlo Park, one of the things we were trying to do was to change the public perception of electric vehicles, because at the time, and actually before I got involved with the other co-founders of Tesla, I had the same view. If you ask people about electric cars, they would say, well, they're golf carts, aren't they? They're heavy, ugly, and slow. And, you know, we really wanted to change that, and I think Tesla succeeded fantastically in doing that. And they actually have one here today if you want to drive one. I'm planning to do that after the session, so have fun. But Tesla's completely focused on cars, and they're trying to drive the cost down and get a higher population of cars out there. What we're doing at Wrightspeed is something completely different. We're actually focused on the community. And the reasoning behind this is that although cars burn a lot of fuel en masse, that's because there's a lot of cars. Individual cars don't burn that much fuel. So we sort of studied the payback equation. If you put electric drive into a vehicle, the costs go up quite a lot. The stuff is not cheap. If you look at what Toyota and Honda can build a little four-cylinder engine for, it's just a few $100s. But you can't build a battery pack for a few $100s, and you never will. So they're always going to be substantially more expensive than conventional vehicles. So you've got to look at, well, how much fuel can I save? How much maintenance can I save? When do I get my money back? And if you study that problem and do a lot of calculation on it, it's quite interesting. The scaling properties are that as you go into heavier vehicles that use more fuel, the cost of the powertrain goes up, but the cost of the fuel that you save goes up even faster. So we're now doing Class 8 full-size garbage trucks, and the reason we do those is they burn 14,000 gallons a year each on average, 2.8 miles per gallon. They do 1,000 hard stops a day. They trigger the ABS on most of the stops. They chew up a set of brakes in 3 months. This is an ideal application for electric drive. We can save them $35,000 in fuel each per vehicle, another $20,000 in maintenance up to. So we can sell at a decent margin into that market and they get a short payback. So that's why we do it. If you look across the spectrum of vehicles, little city cars burn maybe 180 gallons a year. So that's the only coin you have to play with, right? You can't save more than the fuel they burn. So they burn $600 a year in fuel. You can't save more than $600 a year. So you go up to family cars, the Camry is the most popular in the US. It's about 600 gallons a year. You go up to the most popular vehicle in the US every year for the last 30 years. Anyone guess what that is? Yeah, very good. Yes, we're in Texas. F-150s, F-series pickups have been the biggest selling vehicle in the US every year for the last 30 years. So now you're talking about 1,400 gallons a year. You go up to the smallest things that we do, which would be the FedEx delivery trucks, and they're about 4,000 gallons a year. But then you get into garbage trucks, they're 14,000 gallons a year. Now you're talking.
Thank you. And so you have gone into trucks with a keen intention of just capturing a space where you can essentially be a giant in this because there isn't as much action in the electric vehicle, a heavy-duty vehicle class.
Yeah.
I mean, we see Proterra, we see a lot of the bus companies really launching into this space, but where do you exactly fit into the larger heavy-duty vehicle world?
Okay, so the way to figure out where our technology makes the most sense, what we make is a range-extended EV powertrain for trucks. So it's electric motors, inverters, gearboxes, because it's a geared motor system, battery packs, and a generator system. So you run on grid energy until the battery's depleted, then the generator starts. In our case, it's a gas turbine generator. It can burn natural gas, it can burn diesel, it can burn biodiesel, it can burn gasoline, it can burn hydrogen if you can buy it. So we make those powertrains. We make a medium-duty version for trucks like the FedEx trucks, so up to 23,000 pounds gross vehicle weight, 14,500 is the sort of the bottom end of that.
So local delivery up to long distance? Okay.
And then we do Class A, the heavy-duty version of that.
Right.
They have tandem drive axles. We use 4 of our 250 horsepower motors with 4-speed gearboxes. So you could run an 80,000 pound big rig with that, but we don't generally do those. And so the way to figure out where our stuff works is look at how much fuel does an individual vehicle burn per year, and how much of that is in hard stop go driving. So the reason we don't do long-haul trucks is because our system saves fuel in 3 completely separate ways. The first way is you plug into the grid to charge the battery and you drive on electricity you got from the grid. Those are the cheapest miles you're ever going to do. Electricity is really cheap compared to fuel, even now, and it's likely to remain cheap compared to fuel. But batteries are expensive and heavy, so you can't carry enough battery to do the whole thing. So in a big rig, you can maybe carry enough battery to do 30 miles, but they do 600 miles a day, so in long haul. So that doesn't really move the needle much. The second way we save fuel is using regenerative braking. So when you slow down, we use the motors as generators. That energy goes back into the battery to be reused. Pretty efficiently, actually. And the thing about trucks that people who haven't done the numbers don't realize, but they put 1,000 horsepower into the brakes, more than 1,000 horsepower into the brakes under some conditions. And so to do regen braking with electric drive, you've got to have a really high power system. So in our system, in fact, we can pull 1,000 horsepower and put that back into the battery pack, 730 kilowatts, a lot of power. But again, if it's a garbage truck doing 1,000 hard stops a day, this is great. But if it's a long-haul truck out on the interstates at 62 miles an hour,
right,
not using the brakes much.
Absolutely. So duty cycle will, in the end, be a part of any business case and business model that you move forward with.
And the last way that we save fuel is that when you do burn fuel in the generator engine, then we only operate that engine at its most efficient speed and load. So everything is tweaked to get the peak efficiency out of that engine. We run it there, and if we're not there, then it's shut off. And that's actually the same in big rigs. When they're sitting out there on the interstates at 62 miles an hour, 80,000 pounds constant speed, they've got that engine running exactly in the sweet spot. Now, stop go for garbage truck, not so. So those are the three ways we save fuel. None of them really work in long haul. They all work really well in a hard stop-go urban duty cycle. So the heavier the vehicle, the harder the stop-go drive cycle, the more fuel per year. That's the best match for us.
Wonderful, thank you. So Christian, you're our local rising star when it comes to the energy and transportation alignment. You have brought a lot of excitement to sort of rethinking energy and transportation as far as our local ecosystem, but you've done quite a bit broader with KLD, and it looks like you guys are scaling up and ramping up. Please give the audience a little bit more background on KLD. Maybe give your sons a shout out so they know what KLD stands for.
Sure. First thing I want to do, thank you, Drew, for inviting me. I also,
Okay, cool.
I also want to thank Ian. This is the first time, by the way, I've met Ian, never met Ian before. 20 minutes before we started, I met Ian. We do have a common connection. My first CTO was a guy by the name of Rob Ferber. I hired Rob in 2009. Ian hired him years before that as one of the first scientists at Tesla. So we have kind of that common. We also both have our R&D facilities in the San Jose area. But bigger than that, I want to thank Ian for being one of the co-founders of Tesla. Is one of the big reasons that I've been able to be successful. Yeah. Tesla has created a discussion around the world that is extremely beneficial to young companies like KLD getting out there and do what we do. So regardless if they're a competitor to somebody or whatever, we really believe in what Tesla is doing, and we really like Tesla. And Ian, thank you for being one of the guys to start that. So let me kind of give you guys a little idea of who I am and where I started and what KLD is about. So I was with Dell Computer, as Drew mentioned, about 25 years ago. I was one of 6 engineers in the notebook division. Long story short, I left Dell, was a consultant. In 2007, I met an individual who had a motor technology, an electric motor technology. The guy's name was Ray Camano. Very interesting technology. At the time I started having kids, you do a lot of things, you want to go out there and make a difference. And that's really kind of the seed that founded KLD, is I wanted to go out there and make a difference. Similar to the story that Ian says, I actually rented one desk from a buddy of mine for $300 to start KLD. He had his own design firm at the time. So the concept was energy efficiency, sustainability. That's what it was about, right? I had invested about $500,000 of my own money into the company and started the process of defining this motor, this electric motor that was highly efficient. The next thing that happened was I realized when I met Rob Ferber that basically 70% of the world's energy is consumed by electric motor systems outside of vehicles. 70% is consumed by electric motor systems. Just in the United States, this is industrial as well. If we were able to make those systems 10% more efficient, that's $100 billion a year in energy cost savings. That was sort of the key that I lynched on at the very beginning when I started the company. Very quickly after that, when I brought in Rob asked me the question, you know, what about your motor controllers and batteries in these systems? You know, at that time, we were just going to do third party. There was a reason why he said it makes a lot of sense to do it as a system. When I was at Dell Computer, we decided to do everything as a system. It made things more efficient, more cost effective. So we did that. Now, it costs us a lot more money to do that, but that's what we decided to do. We did that. We have a battery motor controller, and that is the basis of KLD Energy Technologies. When I brought in investors, as we always do, we had a very long discussion about naming the company. All kinds of names you imagine thrown out there. So finally,
what were the worst ones? Do you remember any of the best and the worst?
I don't even. I mean,
no, they were so bad you just
there was some of them like Edison Motors, right? They wanted to compete against Tesla, so they wanted who is the guy against it. So there's all those kinds of things were obviously out there. At the end of the day, I just wrote down my sons' names in the order they were born: Kyle, Luke, and Dean. I have 4 sons now, and the other 3 remind the 4th one that he's not part of KLD. But anyway,
is there a T in there, so it could be KLD Technology? It could be like, oh, Timothy is the T in technology.
Brother Timothy, but no. Yeah. So what happened was I wrote that down, right? And the investor liked it. He thought it stood for kinetic linear design or something very scientific. It did not. It was just my 3 sons. Right. So anyway, long story short, we did that. I've been very lucky to raise money into the company. I was lucky that Tesla started to actually become known as because when I started my company in 2007, nobody knew who Tesla was. I mean, somebody knew that he competed against Edison, in the late 1800s, but that's about it, right? And then Tesla has always become very famous now, and it's helped my company tremendously. But that's where we started, in the idea that we wanted energy efficiency by doing system, That's how we started. We're still a big believer in that, and we've now gone into electric vehicles and supporting electric vehicles. Still of the mindset that the way to make efficiency is system. So if you look at, let's say we were to create the perfect electric vehicle, and vehicle for the masses, to go back to what Ian said, there's 197 countries in the world, 196 of them, the best-selling vehicle is a mid-sized Honda Accord Civic. It's not the F Series pickup truck like it is in the United States. So that's the real market out there if you're going to try to sell a consumer-based vehicle. And in order to make that vehicle efficient, you need an efficient drivetrain, which we have. You need low coefficient of drag because wind resistance on electric vehicles is a tremendous amount of energy consumption. And weight. Those are the three things that make the true electric vehicle in the consumer-based class. The truck, obviously, we're talking about two different classes of vehicle, right? We're big proponents of that. We're also big proponents in terms of the smart technology. It's not important for us to develop everything in-house.
Yeah.
There's a lot of smart companies out there, and there's no reason that I have to go out there and our company has to go out there and develop everything. Right? We can partner with the leaders in the industry, whether they be Bosch, whether Continental, and the telematics and whatnot. You know, we can partner with the best designers in the world who know how to design low coefficient of drag, lightweight vehicles. Right? So that's a business model at KLD. It's what we do. We have a core technology we built our systems around, and now we're going out there and working with some of the best people in the industry and strategics to help us get to the next level of what we do.
So in terms of the alignment of strategic planning and your motor system technology, how are you bringing impact to society looking at those two things? Are you able to leverage your strategic planning to really make a greater impact with your existing motor system technology, or are you advancing the motor system technology to drive your strategic planning? Which are you? You're probably doing parallel,
yeah,
right?
as an entrepreneur, you got to do both, right?
Critical path acceleration.
You can't just say, I'm going to do this or that, right?
Right.
So our system's actually in the marketplace today. Our business model in terms of batteries, Tesla's business model is, let's go out there and create a gigafactory and make batteries cheaper, right? Get it, understand it. Business model been used for many years. Ours is the other end of that, is make efficient systems that use less batteries. One of the ways we do that, and I know you went into a little bit about the technology, one of the technologies we use in our battery, we partnered with Samsung on the chemistry, is a power cell. A power cell is different than an energy cell that typically is used in vehicles today. And the reason that is, energy cells have more density so they quote unquote go farther in range. Power cell does not have that. Power cell they call it a power cell because it was used in the power tool industry, still is. There's a difference between the two cells. A power cell has the metric of you can pull 20C out of it, roughly 20C. The energy cell, 3C, something like that. So significant amounts of energy you can pull out of that quickly and also put back in quickly. In an energy cell, it creates heat when you do it. In a power cell, it doesn't, right? So what's the advantage to that is you don't have to liquid cool any kind of power cell. So all our power cells are just convection cooling, right? Weight, water, whatever the coolant is weight. In an electric vehicle, at least in our business model, the electric vehicle weight is a detriment because weight is inefficiency. So we use power cells. At the end of the day, our power cells actually go farther than an energy cell because of the efficiency of the system. So our initial tests are over 200 mpge in the mid-size vehicle that we have today that we're testing. And that's significantly more than anything that's out there today. But in terms of the question on what we're going to do in terms of strategics, we look at both ends of those, right? Our business model with our drivetrain drives some strategics to be involved, and then the other end of that is the strategics, want to then buy our product as well. So it's a bit of both, if you will.
So being on the leading edge, you both must see some things that are flabbergasting on a federal level, perhaps as far as how we spend our money on transportation. Smart transportation is an interesting topic. It's an interesting way to frame a discussion that we're having around advanced vehicle technologies. But I want you guys to sort of humor me, maybe put on your lobbyist cap. Imagine, you're talking to the chief economist for the U.S. Department of Transportation, Arthur Ripinski, and you say to him, hey, I'm really interested in advancing smart technology in transportation. What would you say to Arthur?
So it's interesting you bring that up because recently there was a bid put out by the United States Postal Service, and I'm not smart enough to really understand how the United States Postal Service is funded. because it's not really a government agency, but it's not a private agency.
No, they just lose money.
Yeah, so,
$8 billion a year.
yeah, I'm not really sure how they're
They're good
funded.
at that, though.
Yeah.
They're very efficient. It's a streamlined process.
But I've always been a big believer that the Postal Service market is ideal for electric vehicles.
Yeah.
Right? I think somebody
The
told me
Postal
once-
Service agrees with you.
One of the things about electric vehicles is that speed, the wind resistance is obviously very detrimental to electric, right? Much more than it is to internal combustion engine because of the efficiency of the systems, right? Well, that being said, if you see a postal truck on the highway, chances are it's stolen, because that's not where they go. They only go in the neighborhoods, right? And in this bid, it actually said that the majority of the postal trucks, that the 180,000, they want to redo the Grumman, thing that's been around forever. The majority, I think it was 80%, go 5,000 miles or less every year.
Wow.
So you do the math, that's 20 miles a day on a 5-day delivery in the United States, it's 6 days. So that's 20 miles a day at the average speed of 15 miles an hour with about 500 stop-starts every day. That, you couldn't design a product that's better for electric than that product, right? If I had one thing that says, give the Postal Service the financial capability to do electric, because it is the ideal situation for electric today.
Wow.
So that's what I would say.
That's a great question. That's a great point. I guess for me, though, I was thinking, and I want to get in your thoughts, but
And that's for Ian, because we don't do trucks.
yeah, you just teed them up. But I guess I was thinking on infrastructure too. I mean, one of the main questions we asked in our sort of ETS selection committee was, we said, asphalt or digital? How should Department of Transportation think? And again, we're asking you to put on hey, you get a chance to talk to the chief economist for the Department of Transportation in this rhetorical question. What do you say about the business case of how the strategic performance-based allocation of budgeting? If you're looking at the performance of the dollars you're spending as a federal or state entity, maybe TxDOT, maybe narrow down the scope, right? And I know TxDOT is actively looking at advanced vehicle technologies across its whole fleet. But what would you say as far as infrastructure, longer term transport, if we're going to make smart transportation and it's going to be embedded across our extended community across the country, what would you say to advance our infrastructure so it complements and supports smart transportation?
Yeah, so I guess, and I don't want to take all the time.
We'll switch over to Ian's. I want to hear his.
Just briefly, I believe that the best way and the fastest way to do things is private companies.
Yes.
Right? I mean, the infrastructure in the United States for supercharge, for example, is happening because Tesla did it.
Yes.
Not because the government said, we're going to do it. If the government said they're going to, they'd still be talking about it, and they probably still are. So I believe that the best way to do, and I believe more in the digital than quote-unquote the asphalt, but I believe that they have to enable the private companies to be able to do that.
Yeah.
So give those private companies the capabilities and maybe some incentives or whatever you want to call it to do. Because the private companies are the companies that are going to drive it.
Sort of like the tech-to-market commercialization program that they have at the Department of Energy, so sort of bring something like that. Okay, very good. It's a good point. Ian, I loved your point about smart means electronics and software, but for the purpose of this, sort of using the inflection point of you're talking to the Department of Transportation, you're saying, hey, make your appropriations, make your strategic planning around a bit more, synthesizing the future into what you're doing today. How would you steer Department of Transportation if you could talk with them and lobby them for a moment? What would you say?
I suppose on your infrastructure and asphalt versus digital question, I would say asphalt. So we built the interstate highway system in the 50s.
Yes.
We haven't maintained it very well. There's a lot of bridges in the US that are becoming right at the edge of...
G+ for the Civil Corps of Engineers.
Yeah. We don't even fix the potholes anymore.
Right.
I took out 2 tires on my car the other day just through a pothole. I've taken out wheels on potholes. I don't know if it's a California thing or how things are in Texas, but it's pretty bad. And then, sort of more generally, I would say, think harder about the trucks versus cars thing. Yes, cars burn more fuel than trucks because there's a lot more cars. But I live in California. We have the California Air Resources Board. We used to have big air pollution problems in California. To the extent that we still have them caused by vehicles, it's got nothing to do with cars.
Yes.
The modern PZEVs, you drive those around in LA, you're cleaning up the air. You are literally cleaning up the air. that tightening the emission standards on cars isn't going to help anything at all anymore. It just drives costs up for no benefit. So where does the air pollution come from? Well, it's trucks and old vehicles now.
Yeah.
So think harder about trucks and less so about cars, I would say, would be the second thing. And then the last thing I think would be, beware of unintended consequences. I would sort of go further than you did. My favourite example is the CAFE standards that were written in the 70s, the Arab oil shock, the fuel crisis. And they were intended to reduce fuel consumption, and they actually made it worse. And it's just arithmetic. So if you think about it, they said, oh, well, we want to provide incentives for people to drive more efficient cars, more efficient vehicles. So we don't want to control the individuals, we want to control the manufacturers of the cars. So we'll say, okay, well, your corporate average fuel economy for these vehicles you sell has to be this minimum number. And we're going to cut it up into cars and light trucks, into two things. We'll put this number of whatever it was, 27 miles per gallon for cars and 21 for light trucks or something. Sounds good so far, right?
Yeah.
Well, what's the first thing the manufacturers did? They said, oh, okay, well then we'll tilt the pricing so that, the cars that we sell that are more fuel efficient will reduce the margin on those and make them cheaper, and the ones that we sell that are less fuel efficient, the bigger, thirstier ones, will increase the price of those and try and drive people away from them. And we'll do the same in the light-duty truck fleet. Okay, now you're starting to see the problem. So what happened immediately is that people that would have bought a station wagon or a full-size car, that suddenly got a lot more expensive. But this SUV and this pickup truck that are at the bottom end of the light truck fleet suddenly got cheaper. So they all went over there.
Right.
And so you got this big increase in sales of SUVs and pickup trucks that are less fuel efficient than the heavier cars that they displaced. So although in each fleet the average fuel consumption got better, overall it got worse. And the next problem was they had to define these things, didn't they? So they said, well, what's a light duty vehicle? This light duty truck. Well, they said, well, 8,500 pounds gross vehicle weight. If it's below that, it's a light duty. If it's above that, it's heavy duty and therefore not regulated. What happened next? Well, immediately, so the bigger SUVs and pickup trucks got heavier, so they would move just outside the 8,500 pounds, and now they're not regulated anymore. So they drove the weight up.
Wow.
So in total, the CAFE standards made the fuel consumption worse, not better.
Wow. I've never heard it.
I worked at Ford on CAFE. It was the biggest exporter of jobs ever. If you had more than 53% foreign content, it didn't even count. So the Crown Victoria, Ford made $9,000 profit on a car just because it had 53, not 51% for some reason. Maybe some congressional aide made a mistake and hit 53 on the typewriter. But yeah, and so I spent 5 years of my life automating factories and moving Ford production out of the United States, Canada, Brazil, Europe, everywhere, just any place to get the foreign content over 53%.
And that's an unintended consequence I didn't even know about.
Right.
Well, that was a very intended consequence. I knew what they were doing.
Yeah, right. That was not an unintended consequence.
That's the best democracy money can buy.
Yeah.
That's separate from what you said.
Yeah,
So I'll add a comment. I'm from Toyota. So on the other balance, we're having to put domestic content in our vehicles to balance our.
Because we've shifted that back, right?
Yeah. So we're, it's kind of interesting to hear that. We're in a little different situation where we've got pretty high domestic content in a lot of vehicles, but it's a mathematic and a finance calculation that drives that. So, as these CAFE standards become more difficult, looking at our import versus domestic balance, so we hope to create some of those jobs that you've had to export.
Thanks, Toyota. Come on, Ford.
Base CAFE, this kind of game doesn't go on, it's mostly a currency hedge.
Well,
Domestic content.
Well,
there's a domestic and import CAFE regulation. So you have to meet, on the car side, not the truck side, but on the car side. So you have to meet two different regulations as a car. So it's a piece.
So
and you design for NAFTA now. NAFTA is the big mechanism. You can build a Chinese car and there's rules on how much the form factor changes. So all you do is you get a stamping machine and bend the metal the other direction. It's a different car, so it comes in as an NAFTA car.
So the meta issue is beware of unintended consequences.
Yeah.
If you're giving advice to the feds, really think through what might be the result of these rules that you make.
So looking again sort of at what smart transportation, sort of what something large scale can look at. So something that just sort of makes me arch my back. Uber is valued at what today? Over 15 billion?
I haven't looked at that.
40
I haven't looked. 42? Okay.
43 billion, Alibaba is 45 billion.
And when I go to get a coffee, it's going to be 44 billion, right? And so here we have a real market, the heavy duty vehicle market, and that's measured at roughly what when the market is sort of overall looked at, it's roughly a $5 billion market. Is that right?
Oh, I don't know for the total market. The piece of it that we can address
Yeah.
with the products we have now is about $5 billion in the
$5 billion.
US. Yeah.
So that's not budget dust. That is significant.
Mhm.
In your niche of the market, what could the federal government, if it were looking at savviness as far as a long-term consequence of growing the economy, ratcheting up white-collar jobs as well as blue-collar jobs, white lab coat and blue-collar jobs within our nation, but also sort of extending that access to information and training and R&D. What could we do to really critical path accelerate things in your world? What could the federal government look at?
Stay out of the way.
Really? Really, at the end of the day, that's all you want?
Well,
More than that. It has to be more than that.
well, they can provide some, financial help to private industry, and DOE does some of that. There's
Yeah.
this ATVM loan program. Tesla used that to good effect.
Of course. One of the great success stories.
Right. And that sort of thing I think is fine, but they weren't really trying to direct the result.
No, they weren't.
If you're talking about the federal government trying to direct the result, I think it would be better if they didn't try.
That's a good point.
In general, it's pretty hard for bureaucracies to anticipate innovation. And so, both at Tesla and at Wrightspeed were continually bumping up against things that they didn't think of. And the rules are not written for that. And the rules were written a long time ago when things were different. And so, in California, for example, there sort of aren't emission test procedures for what we do. And we use a turbine engine for the range extender, and that's sort of not done in vehicles, so nobody thinks of that. And turbine engines are, by the way, can be incredibly clean. The one we're using right now beats the California emission standards by a factor of 350% to 1,000% better than the California emission standards without any after treatment. Doesn't have a catalytic converter, doesn't have a particulate filter, doesn't have a urea injection, doesn't even have a muffler. And that's because the combustion process in turbines is very, very different than it is in a piston engine. It's continuous combustion, it's very, very lean combustion, and there's a lot of excess oxygen, so you burn everything that's in there. And yeah, you've got to control droplet size when you inject liquid fuels, but it's a solved problem and you get extremely clean engines. You combine that with an electric powertrain and you've got a very, very, very clean system that will work in Class 8 trucks. But the regulations don't anticipate this at all. They just don't know about this, and it's very hard to get something new like that through the system legally and to the point where you can sell it en masse. Very hard and very time consuming, and time is a critical thing for startup companies. So I don't know. I think they should kind of...
I hear you.
Yeah.
Yeah.
It is interesting because I think a lot of times, like you said, the federal government may do something not understanding what the result will actually be, even though there's one intent. And I guess you sent me a question earlier about smart transportation. I thought about this is more where Ian's world is. But the government, and I'm not exactly sure of the actual dates they did this, but in the 18-wheelers, because there was so many accidents, you remember 18-wheeler guys could drive 20 hours a day and all these kinds. So there's a federal mandate that said they couldn't do that anymore, right? Well, the outcome of that was they became extremely efficient in their use. They started using the GPSs, understanding where every 18-wheeler was. The guy can only go 8 hours a day. They started to actually say when they weren't driving, they couldn't idle their trucks anymore, right? And so what happened there? Well, then they started to have these second-generation systems. They're starting to actually come to us and say, can we use our braking to charge batteries, so then the environment of the cab, when it's not being used, can be air conditioned and all that stuff. So interesting enough, to your point, they don't, a lot of times don't realize the consequence. That one was not about what happened in that industry. That industry is extremely efficient now because of some of those legislation things that happened. So I'm not sure that you can actually drive the government to say do this, and it becomes successful. I think the thing you can do is ask them to help the private industries through incentive, potentially some incentives at the beginning with the consumer base. And the private industry, just like that trucking industry, will make it more efficient themselves without the help of the government, if you want.
Shall we talk a little bit about actual smarts in vehicles?
Yes, you read my mind. I was looking right here. Smart means electronics and software. We're seeing telematics, we're seeing infotainment becoming a important experience of the driving experience. But more and more, I think it also speaks to what we're seeing as far as something you just talked about a second ago was we used to measure things at a different time, trying to get a different result years ago. I feel like what we're seeing right now is sort of the convergence of a communication, energy, and transportation regime.
Yeah.
And we're in the second industrial revolution before, centralized everything, distributed out at an economy of scale. I think Tesla, one thing that fascinating about, everything from how many upgrades they do in a week to the software to the things like being able to, everything from smart software upgrades that enable the car to monitor the availability of charging stations, calculate routes, ChargePoint does some of this stuff, state of charge, Beyond, is this a good idea? Is this a scalable idea? Other applications? The bigger question of smart transportation, where do you see your role in that, and what can you bring to the table on smart transportation?
Mm-hmm. Okay, well, you go and buy a modern car, there's a lot of electronics and software in it. Some of that is around powertrain control, but most of it is around infotainment. So that's sort of slowly getting better. It's frustrating that you can still always have a better navigation result on your phone than anything you can buy in a car. There's such a big lag. So we're not terribly excited about that. We do trucks, and there's not a lot of infotainment in trucks.
Yeah.
Yeah. There's a fair bit of work going into autonomous vehicles of various sorts, autonomous cars. Google's driving right across the country right now, I think, or announced that they're about to do that. We don't do any of that stuff in our philosophy. We take what the driver intent is from control position as gospel. We don't try and second guess them. If they want the vehicle to go there, we make it go there. We don't say, well, there's actually a wall there. So we don't do much with that. But we do a lot with diagnostics and telemetry. So we've got very complete diagnostics in our powertrain. We're continually monitoring everything that's going on. We have a flight data recorder function. We have telemetry, and it's smart right now to the point where if one of the FedEx trucks is out there on the road delivering packages right now, has a problem above a certain threshold, it will actually send an email to my test manager. And should pull the phone out of the pocket and go, oh, FedEx number 13 has got a problem. So it's that smart. And the philosophy behind all of that smart software in the trucks is the thing, it tries very hard to keep the vehicle operational in the face of failures. So we have an intrinsically redundant system. We have a drive motor, an inverter, and gearbox per drive wheel. So that's 2 in FedEx trucks, it's 4 in garbage trucks. You can drive home on 3 or 1 of them if you get a failure. And the system is smart enough to figure that out. And you can have a cooling system failure in a conventional vehicle. It'll warn you, but if you keep driving, you'll destroy the engine. In our vehicles, you won't. It will reduce torque, it'll reduce speed, it'll do whatever it needs to do to try and keep the vehicle going. It will alert us, it will alert the driver, it'll go into the flight data recorder, everything that's happening. But it will get you back to the depot if it possibly can. And if it can't, because things are getting too hot, then it will eventually shut down and you can't damage the vehicle. So when we take our vehicles out to ride and drives and let people drive them, one of the things we say to them is, you can't hurt it. If you don't run into anything, right, then you can't hurt it. Do whatever you want. The system will protect itself. So that, I think, is a whole area where there's a sort of big change going on in smarts in vehicles. it's different to the conventional things.
And I'm glad you bring up fleets, because fleets is sort of the, like you said earlier, it truly is sort of the forgotten story, and it's a lot of what drives our American economy.
I'm actually surprised that I see outside of the US, the fleet operators are more advanced in terms
Yes.
of telematics.
Yeah.
A lot of the US fleets are not doing much of this at all yet.
India, Sweden, Norway, absolutely.
In New Zealand, where I come from,
Oh, yeah.
I've got a potential customer down there who runs one of the big trucking fleets, and you would be astounded how much he knows about what all his vehicles are doing, what his drivers are doing at the moment, how long they stop at Starbucks.
So in Austin, we did some fleet optimization analyses with the Central Texas Fuel Independence Project. And Dave Tuttley, you were involved with some of that. And one of the things that we were really illuminated by was seeing about 50,000 vehicles worth of vehicles, or fleet managers actually getting together and really talking about duty cycle and fleet optimization. That information sharing, it's a very old school way to get to the solution, but it's very valuable.
They do that, absolutely.
Yeah.
NDAs or non-NDAs, they talk to each other.
And the fleets actually really do know each other, and they know each other's audience really well.
Yeah.
As far as the smart technology.
So there's an audience question there.
Oh, yeah, absolutely. Dave.
So, quick question, while we got two experts in here.
Please.
So, computing has Moore's Law to X/18.
Yep.
The solar industry has, say, 20% reduction with doubling of the volume. Two key metrics that I'd like to see if you have a rule of thumb for, and it's changing over time. What do you think is an approximate amount of the decline in battery prices on dollars per kilowatt per year, and then power electronics and controls, the cost decline of those? And then also, I read a Ricardo study a few years ago. It was based in Europe, but it talked about, here's the trajectory of conventional vehicle costs with all the different after treatments and requirements. So increase, and it seemed like that there's a technology curve for batteries, power electronics, and such not. And then say by 2025, they could kind of get close enough to where the cost premium has got a pretty quick payback, and you can always adjust it. So do you have any rules of thumb on the battery cost and the power electronics cost?
I'm not sure that I can distill it to a rule of thumb, but I can talk about it a little bit. So one obvious mistake that a lot of people make is they know about Moore's Law, and they think that, well, the electric cars are going to follow Moore's Law, and it's not true.
No. It's maybe 5% a year or something.
Yeah, that's probably not bad for batteries. So the problem with batteries, of course, is, well, let's go back up. Why does Moore's Law work? It's because we keep shrinking the geometries. So you get 4 times as much stuff when you, yeah. So that's why it works. And the end is not in sight for that yet. Well, depends how far you can see, but it's been working pretty well for what now, 30 years? Yeah. The batteries don't have that at all. So the first thing is there's a lot of raw materials in batteries. There's, I don't know, whatever it is in a Tesla, 800 pounds of raw materials go into the batteries.
And a first principle right there.
Yeah. And the second thing is, if you've ever been to a battery factory, there's a lot of capital in a battery factory.
Yeah.
So you've got two scaling problems right there. You can't do much about the raw materials. That's not going to get better with volume or with time. It's going to use that much raw material. You might get a little more energy density out of them, so you use a little bit less, but what tends to happen instead is you use the extra range. So you still use the same amount of raw material. And the capital cost of building a battery factory for a certain volume is so high that you've got to recover that. So that you build that into the cost of the kilowatt hour, and it's pretty significant. So I guess we've seen maybe 5% a year. What we've seen, and what really enables our business, is the new battery chemistries that give us the power. So in the battery pack we put in a Class 8 garbage truck, we're putting 730 kilowatts of regen power back into the pack. And you couldn't, when we started Tesla, there was absolutely no battery that would do that. There just wasn't. So A123 and then the lithium titanate chemistries, and suddenly you've got some really high power batteries with a really long life. You can do repeated high power cycles and you still get 6 to 10 years out of them, 15,000 cycles. They're really awesomely good. They don't get cheaper, but they got better in certain dimensions. So there's that. In terms of power electronics, you know, it's kind of hard to shrink the power transistors.
Well, with the new wide bandgap devices.
Yeah.
And so it seems like there has to be a new architecture for the base devices, and then you can integrate more and shrink.
Yeah, and there's you know, new technology, you know, silicon carbide. When we get the volume and cost of that down, that'll be pretty interesting because the cooling problems get a lot better. You can switch a lot faster, and you get less losses in the motor, and so on and so forth. So there are some things that will continue to drive the cost down. But you know, inductors are still inductors, capacitors are still capacitors, and magnets are still magnets, and you know, motors. And we get the sort of performance we get by running a 25,000 RPM motor, so we get 250 horsepower out of something you can pick up 70 pounds, and then we gear that down. And this is just the same approach that you use in a cordless drill, right? They use a tiny little motor at high speed and then planetary gear trains to get down. They could make a motor that would give you the torque and speed you want out of the chuck, but they don't, because that would be more expensive and heavier. So we do the same thing, essentially. So you've got to watch the losses and where is the sweet spot. But there's nothing, you know, we make architectural decisions, we make detailed design decisions, we make a lot of consistent system decisions, but there really isn't anything in motors or power electronics that's revolutionary. And what's been revolutionary in the batteries has been first the lithium and then the high power stuff. But, you know, step back a bit. Our business model is based on the payback time to commercial customers. There's a capital cost for buying this stuff. There's a savings in fuel and maintenance when you get your money back. And it's influenced very heavily by the cost of batteries and the cost of fuel. So of course we're always interested in, well, if we were doing, you know, family electric cars, when would that happen, which is sort of the question you asked. And right now, you know, the fuel would have to be $11 a gallon, or the batteries would have to get down to, well, actually where Tesla's trying to drive them to, 100 and change per kilowatt hour, which is, you know, it's a quarter of what it is now. So you know, we're a very long way away from that sort of tipping point, and we're not on any steep enough curves, I think, to get there. And as far as the cost of conventional technology, and you mentioned the after treatment and the way the emission standards drive that, yeah, I can't predict where that's going to go. As a practical matter, there's no point in tightening those standards anymore in cars. There just isn't. But they probably will anyway, so it'll probably drive those costs further up. So I don't know.
Well, there's a need for lightweighting next.
Yeah.
So Christian, thoughts on that?
Yeah, so as I mentioned before, our business model, we believe that the battery, and I've been to many battery facilities, and if you've ever been to one, I was one, and I won't mention the name of the company, but it was in Korea. And I'm sitting there. I mean, there's football fields. In this case, it's what's called an 18650. It's a cylindrical cell, 18 millimeters in diameter and 65 millimeters long. That's why they call it an 18650, right? 100% robotic. When you're in that factory, you'll hear click, click, click. That click is every time it goes to a new station. Every battery in that whole entire facility is actually being monitored for something and being tested. So 100% test, 100% robotic. To bring that cost down based on production and raw materials, it's not going to be significant over the next 10 years. It's just not going to be. I think 5% is probably kind of a good rule of thumb to use for that. So it's our business model not to believe that someday there's going to be some huge kind of change in battery technology that allows that cost to come down. So what we've done is say, let's make efficient systems, system efficiency. And in terms of the power electronics, we've actually looked at some of that. If you look at, for example, battery has a battery management system, motor, and ours actually has the motor controller, right, and charger. There's a lot of electronics over those three pieces. If you do those together, you save tremendous amount of cost by doing them as one unit, per se, right? That's our business model, efficiencies of system and design, and efficiency overall system. Then we test, and we have products getting over 200 mpge, which means it uses half the battery.
And you're looking at testing soon.
So yeah, we're doing quite a bit of testing. We're very lucky. Anyone who has vehicles knows you have to test on a track. We're lucky we live in Austin, Texas, with the only F1 track in the United States. So we're looking to try to do something there.
That's very encouraging.
But anyway, so that's our business model, because I don't believe the battery cost is coming down significantly. So that's
I agree with all the points that have been made about the particular existing batteries and the limitations that there are for batteries versus chips when it comes to Moore's law and stuff and cost reductions. But that being said, I mean, I guess are any of you all, are you following and like in terms of your business, are you aware of some of these potential breakthrough lithium technologies like the new solid state batteries people are working on that could use a lithium metal anode, which would really significantly increase the energy density, and they're also manufactured in a completely different way because it's an all solid state design.
Right.
And so then there is this potential for this kind of breakthrough.
Yeah, absolutely. I mean, it would be naive of us not to look at the new technologies. But I can tell you one thing, I won't bet my company on a new technology, right? That's someone else's,
Yeah.
only on my own technologies.
Well, especially with batteries where there's been some kind of,
Yeah, because if you don't have a battery, it's hard to actually have a company. Look at Fisker, look at some of the other companies, right?
So we've been, of course, watching this since 2003 when we started Tesla, and you know, we've been pitched by every battery startup and every new chemistry and every supercapacitors. That in Texas, actually.
Oh, yeah, E-Core,
Yeah.
E-Store, sorry.
Yeah, E-Store.
Yeah, they're very famous.
Yeah, and you get fairly
Infamous.
cynical
Infamous, right?
after a decade or two of this, and so at this point, I don't get excited about any of that until there's a cell that they can give me that I can test in my lab.
Yeah.
Until there's a cell that I can test and get my own numbers on, I just don't waste any time on it, because there's been so many of those stories that for one reason or another didn't pan out.
Yeah, and that's why Smart Tesla went with Panasonic, name brand, right? We're partnered with Samsung today. None of those companies are going out of business.
And actually, I think it was your point, you know, I don't think anybody believes in this $100 a kilowatt hour thing, that it's going to happen. Why is Tesla going to all this trouble and expense to build their own battery factory? If they thought it was going to happen, they would use it.
And to another point, and Tesla's done this, and I don't want to say KLD's modeling after Tesla, it just makes sense. We actually, KLD was funded by mostly angel investment, very unique story, mostly from Central Texas, lots of billionaire type people. But anyway, the long story short is I also believe there's a reuse opportunity in batteries, right? And we actually started a company called KLD Nanogrid Systems only because we had customers that were investors that wanted power management systems in the industrial field, right? You allow the batteries to have a second life and reuse, not recycle, and it can reduce the cost of the upfront cost. So there's other ways to do that, but I don't believe betting on the hope that it comes down someday is the best way to do it.
We have time for one last question. Yes.
So in the context of this conversation, can you comment on Tesla's gigafactory plans?
In what aspect? In the
Well,
context of the lithium, the cost, or?
Yeah, and why are they making such a big investment? Obviously, they believe that the cost is going to go down, right?
Well, I mean, I don't have any conversation with them, but the reality is lithium batteries are going to continue to be bought around the world, and it's only going to have, my guess is that it's going to be more demand. So I think it's as much, they're going to be able to sell batteries as much as reduce cost by high volume.
So you don't think we're going away from lithium-ion batteries? We're not going to find some other super?
So they're using the 18650?
Yeah, and I'm not telling you anything that they haven't published many times. They use an 18650 from Panasonic.
So that's a mature curve.
Yeah, in terms of now, quickly to the other point, there's pouch technologies out there. The 18650 is not going to reduce in cost in actually assembly because they've been making them forever.
Yeah.
There's pouch technologies that LG Chem and companies like that are using that are not kind of at the state where they're cheap enough yet because they have not been out there long. So they actually could come down, I don't know if it's possible, in their packaging costs, companies like that. The 18650 I don't see tremendously coming down.
I cannot figure out how they make decisions on cell cost versus package cost. And I'm really interested, if you've got a high energy battery, that's...
No, we use high power batteries. So ours is a range extended EV, so we don't have a range problem.
Right.
And one of the ways we save fuel is through high power regen. So the limiting factor for our battery is what is the peak charge rate that we can do on a repeated basis for regen power. What's the smallest battery pack we can build that will take 730 kilowatts of regen power? So power cells are what we use.
So your design is a supercharger on steroids?
Yeah. Yeah, trucks put, well over 1,000 horsepower under the brakes under some conditions.
And you said they replace the brakes, what, every 3 months?
Some of our garbage truck customers, some of the fleet operators, yeah, they say that they, on some of those trucks, they don't get more than 3 months out of a set of brakes. And when they buy those trucks, they buy the biggest brakes they can get, not because they've got long hills to go down, it's just to get brake life out of them. Those guys they really are full throttle for 4 seconds and then full brakes until it stops, and they've got it perfectly calibrated. When they leave the curb, they're on full throttle, and they know the last millisecond that they can leave it on full throttle and go to full brakes in order to stop there.
I'm very aware of that. Every Saturday morning when I go back to sleep, full throttle, screech on the brakes.
So one of the things we didn't talk about is I think once the cities and communities figure out that you can make quiet garbage trucks, they're going to start wanting that.
That's where they're going with CNG, but I think we can make them clean.
I was having that conversation with one of our potential customers and said, oh yeah, we get a long way towards that with CNG engines. I happened to be traveling, I was in Southern California in a hotel, and I got woken up in the morning by a garbage truck, and I look out the window.
Oh no.
And it was a CNG
Lies!
truck from the fleet that I was talking to.
Oh really?
And the loudest thing was the engine still.
Yeah.
I mean, there's the crash of the bottles and the recycling,
Right.
but they run the engine at high idle to get the hydraulics to work fast enough. So even when they're not driving, they're sitting there with a thing at 1200 RPM or something to make the hydraulics go.
So your hydraulics direct drive off of the electric?
Yeah, we use one of the traction motors. We use another motor, the same motor we use for the traction motors, and that's geared down to drive the hydraulic pump. They need about 60 horsepower. That motor makes 250, so no problem. But we can control the speed of that for the demand. And anyway, it's pretty quiet. The motor itself is silent, it's just the hydraulics.
I will allow everyone to continue their conversation, but for now, that ends our session. I want to let everyone a chance to follow up with where they need to go next. Please do note that the 10 a.m. is in the ballroom. It'll be a plenary. But for now, I just want to say thank you, Ian. Thank you, Christian. We covered a lot of ground very quickly, but I do hope you'll take the opportunity to touch base with them later on today. Thank you both very much.